Hello everybody, my name is Roberto Sáez, and in this presentation we are gonna introduce you with our new analytical application that we have developed for the analytical chemistry laboratories. In particular, we have named this application ColorAnalysis. The educational context in which we have worked is the chemistry degree. More in particular, we have focused on the analytical chemistry laboratories. In these laboratories, one of the topics that are dealt with have to do with colorimetry. That is, in our particular case, we use color as an analytical variable. We use color as an analytical tool in order to either identify compounds or quantify those compounds. The teaching objectives that we have stated for this application have to do with the application of colorimetric techniques to investigate analytical problems and to compare different instrumental approaches from an analytical perspective. For example, one of the case studies that we can address with this approach deal with the degradation of dyes using different treatments. In this case, what we do is we apply different degradation techniques, different degradation approaches, and we observe how those dyes are degraded. That final measurement can be done using colorimetry. In particular, we can compare two different technical approaches, two different instrumental approaches to measure that color. One of them is ultraviolet visible spectroscopy, that is, recording the continuous spectrum of each of the individual dyes across different wavelengths, or we can implement also image colorimetry. By this later approach, what we can do is extract color descriptors, that is, extract condensed color information that is reflected instead of in a continuous manner, like in the case of the spectrum. We condense it, we use it in a few parameters. Maybe the most known example is the RGB color space, in which all the information in the spectrum is summarized into 3 different channels. Then the pros or the advantages of this approach allow us to introduce students to colorimetry techniques, not only to the theory but also to the practical aspects. It also allows us to analyze color as an analytical variable, that is, we can address how color can be analytically implemented. And we can of course analyze UV spectra and their relationship with color descriptors. We can compare those two techniques that I was talking about in an analytical manner. Last, we can also use the students' smartphones as analytical devices. This we have previously demonstrated that enhances motivation and involvement. However, this also implies some difficulties in the methodology. For example, using different smartphones, using different students' devices, introduces a device-dependent response. That is, each and every device will provide a slightly or not that slightly different response. Also, there are some difficulties in extracting reliable color information. There exist some available free applications, but those are not always reliable. The information that we can get from them cannot always be trusted. And also, those available free applications usually provide only the RGB color space. Despite RGB being really useful, there are many other color spaces which actually reflect color changes, maybe in a most adequate manner. Thus, in this context, we decided to develop what we called ColorAnalysis. ColorAnalysis is a graphical user interface, that is, it's been coded behind the scenes, but the user only needs to use click and buttons. It's based on MATLAB, and it allows us to analyze color of different samples. We take an image of the sample and we can then extract the colors. As the output of this process, of this protocol, we get not only the RGB parameters, but also some others like X, Y, Z, chromatic coordinates, or CLAB color spaces.
So let's take a look at the different steps the user needs to follow when using the ColorAnalysis app. So each section is designed to guide the user through a structured process, from the image selection to the color analysis and spectral estimation. First, when the application is launched, a screen is displayed, showing the title of the app and also its logo. At the bottom of the screen, there's a button labeled Start, so clicking it will take the user to the next tab of the program. In the next step, which is called image selection, the user must upload the image they want to analyze following the on-screen instructions. Then proceed to select the regions of interest from this image. So once the image is uploaded, it's time for select the colors of interest. First, they need to choose a white reference, so this part is really important for calibration. If there's a color chart available, they should pick the white color from this chart. If not, they can choose the white background as a reference. Now they have to pick which colors of interest they want to analyze. So by clicking on a pixel, the app will automatically choose a 10 by 10 pixel region and then make the average of these points selected. The app will ask the users if they want to analyze more color points. And finally, a pop-up will appear asking the user whether they want to save the results on an Excel file or not. In this tab, the user can see the results from the colorimetric analysis for the points they chose earlier. The data is displayed in columns, each one representing with each color they chose from the image and also the white reference point. The data shown in rows represents the color descriptors such as RGB values, XYZ trim-stimulus values, and also chromatic coordinates and luminance, X, Y, and Y, purity, color, dominance, luminance, and also CLAB descriptors. So the data is displayed clearly so the user can compare each color with its characteristics. So once the user reviews the data, they can now pass by clicking the button Continue to the final step of the program. So finally, in the last tab, the user can estimate the spectrum of the color. So first they need to select which color they want to analyze. They do that by clicking or choosing from 1 to 9, depending on how many colors they chose from the previous image. They now can click on Import XYZ values, and the three stimulus values will automatically appear on the XYZ fields. Now the user has to choose and predict which is or are the main hues from the color they selected. So finally they can click on Calculate and the graph will appear. The graph will show the absorbance of the color selected along different wavelengths. And finally, below this graph, there's also a visual patch that shows the color they selected along with the best match of the color database from the Munsen. So finally, this is a summary of the ColorAnalysis app. So first you initiate the program, and by clicking Start, you begin. So now you upload the image following the on-screen instructions, then you select the points of interest, and don't forget to choose the white point of reference for calibration, and then you can review the data and see the results, and finally estimate the spectrum from the color you want to analyze. So finally, regarding students' opinions or assessment of the results for the application, this was done via surveys conducted during analytical chemistry laboratories. So first, regarding learning experience, answering the question, did this task facilitate your learning compared to traditional methods? 100% of the students reported enhanced outcomes regarding their learning experience, with the 61.4% indicating improvements, yes, a lot. So demonstrating these tools' advantages over traditional methods in this type of laboratories. Then, regarding activity design, answering the question, was difficulty level appropriate for your academic level? 93.2% of the students confirmed the difficulties level of the app matched their academic preparation, validating that the application successfully bridges their knowledge within the practical application. For user experience, answering the question ease of obtaining RGB color data, 63.6% of students found the process intuitive, easy or very easy, confirming the app's friendly user design. Then, with the 22.7% of non-responses, this highlights the possibility of improvements for the app's design. Also, for overall satisfaction, the question was originality and innovation perception. The graph shows that 90.9% of the students acknowledge the tool's innovation, with very innovative or slightly innovative, with 68.2% emphasizing its groundbreaking potential, also confirming and reflecting a strong enthusiasm for transforming educational technologies. Finally, for tech adaptation, answering the question, would you like similar tech-based activities in the future? 95.5% of the students endorsed future implementations, yes, definitely, or yes, with improvements, underscoring its high adoption potential for smartphone-based methodologies in analytical chemistry. So finally, with the conclusions, we have seen that the development of this application successfully addresses pedagogical challenges regarding teaching colorimetry in the analytical chemistry laboratories. So this enables students to intuitively obtain color descriptors and absorbance spectrum with their own smartphones. Implemented across diverse teaching practices in the degree of chemistry, this tool has demonstrated both robustness and also educational values. Notably, with the results from the surveys, they revealed a strong student engagement and also with particular enthusiasm for transforming their own devices that they use every day into analytical instruments. Finding that also underscores the tool's ability to modernize laboratory training and also bridge their knowledge, their theoretical concepts with practical applications in the field of chemistry. So that was all. Thank you so much for your attention.